This is our Unit 8 Gas Laws Review video. This is going to be pretty quick. I'm not going to do a whole lot of practice problems. I'm just going to kind of go through the basics. If you want some practice problems on gas laws, you can go back to any of the videos from Charles, Boyles, Gay-Lussac's, Avogadro's, or the ideal gas law to get those additional practice problems. So we'll start off just what we had in Unit 8, what we covered. We covered the four main gas laws. We had Charles, Avogadro's, Gay-Lussac's, and Boyles. The main thing with these four is just to remember the relationships that exist in terms of the different gas laws and the variables. So you can see Boyle's law here. It is the only indirect or inverse relationship, which means as pressure increases, the volume will decrease. So if like the pressure increased, if the pressure like doubled, then the volume would be cut in half. If the pressure was cut in half, then the volume would double. So like if the pressure went from 1 to 0.5, then the volume would go from 1 to 2. It would double. That's like the question we had in our review. Charles is volume and temperature. It's a direct relationship, so if volume increases, temperature increases. Avogadro's is also a direct relationship, which means if the number of moles increases, then the volume will also increase. And Gay-Lussac's is also a direct relationship. Bring that up just a little bit so you can see it. If pressure increases, temperature also increases. So these three all have direct relationships. So if one increases, they all increase. Boyle's is the only one that is indirect or inverse. We're just going to go through some of the stuff we'd already seen back when we introduced it. So just some basic things. Remember that the ideal gas law is PV equals nRT. So whenever you see the term ideal gas law, it's referring to PV equals nRT. P is pressure, we want to measure that in atmospheres. V is volume, we want to measure that in liters. So if you see milliliters, you need to divide by 1,000 to get it back to liters. N is the number of moles. R is the gas constant. This is the version we originally started with, but you would want to use in the equation, that's where you want to use 0.08206. That's what you always want to use for R, which is the gas constant. The temperature measured in Kelvin. To convert from Celsius to Kelvin, we've practiced this a ton of times. You add 273. So if you're given 20 degrees Celsius, you would add 273 plus 20 to convert to Kelvin. So your your Kelvin would be 293 Kelvin. Something we haven't covered in a while, and something that you are going to see on the exam, is standard temperature and pressure. Standard temperature is 273 Kelvin. Standard pressure is 1 atm. And at STP, the volume is 22.4 liters. So those are the conditions. If you see STP, that means standard temperature and pressure. So just be aware of that. Those are the conditions there. Some other things. How can pressure be measured? These three different ways. To convert from millimeters of mercury into ATM, you just divide by 760. There's actually not any kilopascals on the test, so you don't need to worry about that. And you don't have to do this conversion either. This is the only one you need to worry about. To get from millimeters of mercury to atmospheres, you just divide by 760. Avogadro's law, direct relationship. Here is the formula that you would use right here. I wouldn't look so much at this one. That one can get kind of confusing. So we'll just stick to this one. V1 over N1 equals V2 over N2. Some examples of that on here. You can see the drawing's already been on here. These are the same examples. You can go back and watch them in Avogadro's law. You just have to identify the three numbers. So like 1.93 moles would be your N1, 3.9 would be your V1, and then 1.5 moles would be your N2. And then all you do is cross multiply and solve. So we're not going to do too many practice because you can go back and watch those, but it's just cross multiplication and solving. Those are all the Avogadro's practice. Charles' law. Charles' law, here is our equation right here. You're going to want to know the Charles' law equation. You have that. Again, this is one where you just identify the numbers, and then you cross multiply and solve. It's volume and temperature, and it's a direct relationship, meaning as temperature increases, volume will also increase. These are some of the practice problems that we had. You can go back and watch some of those. All it is cross multiplication. Boyle's law. Boyle's law is the only one that is indirect or inverse. It is not direct, meaning as pressure increases, volume decreases. As volume increases, pressure decreases. This is how you need to set it up. This is the only one that you're not going to cross multiply. You have to set it up just like this. There's no cross multiplication involved. Just P1 times V1 equals P2 times V2. Indirect relationship, if pressure was 1 and then we traveled somewhere to where it was 0.5, so the pressure decreased by half, that would mean the volume would increase by half, or it would double. So the volume would double. Just put dBl. So if you went from 1 down to 0.5, then the volume would end up doubling if you did that with the pressure. Conversions, just remember, you divide by 760 to convert from millimeters mercury into ATM. Boyle's law, again, this is all very straightforward. Gay-Lussac's law, just identify it. Pressure over temperature equals P2 over T2. Cross multiplication, same thing. You can identify those numbers. See here, you identify your P1 and then your T1 and your T2. We plug it all in. We add 273 for the temperature. You're good to go. If you need to see these practice problems again, go back and watch those other videos. So that is it. The only other thing I would add for our review would be make sure you know the ideal gas law. This is what it's called, is PV equals nRT. And remember that R always is 0.08206, gas constant. That's always the same. And then temperature has to be measured in Kelvin. Yeah, I don't think that there's anything else. They are all just plug in and answer questions. So if you can identify what law to use and where to plug in the numbers, you should be fine. There's 16 questions. We should be good to go here. Ideal gas law, PV equals nRT, R is the gas constant. If you need to see ideal gas law questions, go back to the ideal gas law video. So that's our review. That's basically just a synopsis of the unit, just the different laws. You should have all those in your notes, and you should be good to go. Gas law test. Farewell.